Hello and welcome back to another Project Data Science tutorial video. So my name is Steven and today's video is part of our 80/20 series where we show you the most common parts of data science packages to get you up and running quickly. And today we are talking about NumPy. So really quick, 80/20, what does that mean? Well, this comes from something known as the Pareto principle, and it basically means that very often there's a small set of functionality, let's say 20% of the functionality of something, that will get you 80% of the value. So that's what this series is based off of, is showing you, let's say today, the 20% of NumPy that's going to get you 80% of the value that you're going to get from NumPy. So basically just like very efficient learning. All right, before we get started, if you need to get a data science environment set up on your computer so that you can follow along with this video, which I highly recommend that you do, then you can see a link in the description to get the same kind of data science environment set up that the professionals use. So click that link if you need to do that. Also, there's a blog on the Project Data Science website that covers basically the same information, a little bit different. So you can click that as well if you want to have just another resource to use. So before we get hands-on here, what is NumPy? So essentially, NumPy is a faster, better way to work with numeric data in Python. So you can work with numeric data just kind of in Python itself using lists and using sets and dictionaries and things like that. But what NumPy does is it gives you a better way to work with your rows and your columns and your vectors and your matrices of numeric data in a way that's not only much faster computationally, but that's also easier to use for a lot of the kinds of things that you might typically do with numeric data. So not only is NumPy very powerful, but it's pretty much ubiquitous in the Python data science ecosystem. So a lot of other packages and tools are basically going to be built on top of NumPy. So pandas is a great example of this. The pandas Python package, which is extremely common, is essentially built on top of NumPy arrays. So whenever you're doing data science in Python, whenever you're using numeric data in Python for data science, you're very often going to be using NumPy arrays, and that's why it's important to learn. So here at Project Data Science, we want you to learn through doing. Cha-ching right there. So let's go ahead and dive in. Let's get hands-on. I want you to be following along, by the way, using your own environment on your own computer. So definitely be hands-on. That's how you learn the best. So let's go ahead and spin up a Jupyter notebook. That's where we'll be doing the majority of our work today, just because it's nice and easy to kind of get into a flow and kind of see what's happening there. So first things first, I'm going to open up a terminal here. There we go. And let me go into my Project Data Science directory. Let's look around. I'm going to make a new directory, call it 80/20 NumPy, and then let's cd into that. And what I'm going to do is I'm going to activate a virtual environment. Let's see. I've got this updated Scikit-Learn Conda virtual environment that I think should have everything that we need, which is basically just Jupyter Notebooks, NumPy, and we're going to be importing data from Scikit-Learn, so we'll need that installed as well. So, so this virtual environment should have those things, and then I'm going to go ahead and run Jupyter Notebook with this ampersand here to start a Jupyter Notebook server locally on my computer and to do it in the background, so that I can still use this terminal if needed. All right, so it popped open over here on my other screen. Let me drag this over. And here is our Jupyter Notebook, our Jupyter Notebook dashboard up and running. I'm going to go ahead and go over here and create a new Python 3 notebook. And let's just call this 80/20 NumPy. And save it. All right, so we are good to go. We have our environment basically set up. So really quickly, let me just test my imports, make sure I've got everything that I need. Let's import NumPy. And let's see if we can import Scikit-Learn, and it looks like we're pretty much good to go here. So I'm going to delete this import for now, but all right, so NumPy. How do you import it? Well, just like this, import NumPy as np. And by the way, if you need to get NumPy installed, let's look up conda install NumPy. If you have your data science environment set up with conda installed, like we show you how in the blog in the description, then basically you can either use pip or conda, I believe. Yeah, so here's conda install -c conda forge NumPy, or I think you could probably also just run pip install NumPy to get it into your virtual environment. So import NumPy as np. And so this np here, this is just an alias for the import, and this is how pretty much everybody imports NumPy. It's just kind of the convention. Similarly with pandas, if you watch the 80/20 pandas video or look at the 80/20 pandas blog, the convention there is to import pandas as PD. You know, these are just conventions that data scientists and Python programmers typically use. So we have imported pandas here. So one of the first things that you want to do when you're dealing with a new Python package or just a new tool in general is to ask, number one, what is this for? And we've already discussed that a little bit. NumPy is for fast, efficient, and user-friendly manipulation and computation of numeric arrays, numeric data. So that's what it's for. And so we ask, what is it for? And then we also ask, what are the primary objects and what's the primary functionality of this package or of this new tool that you're using? And in this case, with NumPy, the primary object is going to be this thing called an array. And technically, let's use the question mark syntax here to look at the doc string. So if we take a look, all right. So let's look at this returns section here of the doc string. So what does this return? Well, it returns an nd array. So this nd array, or we usually just call it an array, this stands for an n-dimensional array. And specifically, it's an n-dimensional array. It's of a homogeneous data type. So there's only one type of data that you can put in your array. And what does n-dimensional mean? Well, it just means that you can basically have one dimension, which is just like a list, or you can have multiple dimensions, which you can think of kind of like a matrix from math, if you kind of remember what that is. So one dimension might just be like a row of just a single list of data. 2 dimensions, that's going to be where you've got your rows and your columns, where you've got your 1, 2, 3 as a row, and then your 1 and your 4 as a column. So you've got kind of multiple dimensions, and then you can have 3 dimensions, 4 dimensions, kind of however many dimensions you want to have in these n-dimensional arrays. So the primary object that we're working with here is, and I'm going to write it here in a comment, n-dimensional homogeneous array. And let's close out this documentation. And I'm going to go ahead and create a very simple NumPy array here by just passing in a normal Python list. So I'm just going to pass in a normal Python list to np.array, which is then going to return that n-dimensional array NumPy object, which is here. So it prints it out, and it looks just like our list, except for now we've got this array wrapped around it, which lets us know that we're now dealing with a NumPy array. But this isn't usually how we're going to create NumPy arrays. Usually we're going to have a data set of some sort. We're going to have a CSV file that we're reading in, or we're going to have a database that we're pulling some data from, or something like that. So let's get some data in a format that we might actually work with in a project. And to do that, we're going to import a data set from Scikit-Learn. So what I'm going to do is I'm going to say from sklearn.datasets. So Scikit-Learn has some datasets already built into it just for playing around with, for testing out machine learning algorithms and things like that. So we're going to import the load wine function here. So let's go ahead and call that, and we're going to assign it to this variable called data bunch. And if we look at what this data bunch is, this is typically how Scikit-Learn returns data. It's just a dictionary that has a bunch of different stuff in it. So we have our data key, this is the main thing we're going to be dealing with, but there's a bunch of other things here as well, like the target. If you're doing, I believe this would be, let's see, supervised learning, some classification here. Looks like that's what this problem is. And here are our feature names, and this is a description. But anyways, we're just going to be using the data key. So let's go ahead and access that, and we'll pull it out into a wine data array. Now, if I print this out, you'll see that this looks kind of like what we have up here, right? Looks like we're dealing with a NumPy array. But now that we're dealing with some actual data, you can see that things look a little bit more complicated. So what are we looking at? Well, one of the first things we can notice is that it does look like we have some nested looking lists here, which means that we're dealing with multi-dimensional data. But you don't have to be afraid of this scary term multi-dimensional, because we'll break it down here. So let's first of all just look at the first row of our data, and we're going to do that in the same way that we might look at the first item within a Python list. Or if we had a list of lists, which is kind of how we can think of this, then we're going to be looking at that first list in the data set here. So we're just going to access that with the square brackets syntax here and pass in that first index. And you'll see that we have, what is this? Looks like 13 different items, 13 different numeric values in this first item, kind of the first row of our NumPy array. And if we actually go back to our data bunch and let's look at the feature names. So this is actually what we're looking at. These are various qualities and characteristics, mostly chemical properties of a bunch of wines. So that's pretty cool, right? Pretty tasty. So let's go ahead and delete this. And if let's look at like the index 10 here, and we see that we return basically the same thing. We could look at index 100. So it looks like basically what we have here is a bunch of these arrays, and each array contains 13 values, which are these chemical properties of the wines. So one way that we could tell the high-level shape of our data is to just use this wine data array dot shape attribute. So if we look at the shape attribute, this is actually going to tell us a couple different things. So number one, it's going to tell us the number of dimensions that we have, and that's just the length of this tuple that gets returned. So you can see that we are dealing with two-dimensional data. Here's our first dimension, and here's our second dimension. And for our two-dimensional data, we have 178 rows, and we have 13 columns. So translating this into the data that we're dealing with, there are these 13 chemical properties of wine. So these can be thought of like our columns in an Excel spreadsheet, for example. And this 178 rows. So we have 178 different kinds of wine, for example, that we're looking at in our data set. So with this multidimensional NumPy array, you can essentially think of it kind of like an Excel spreadsheet, right? With rows of data, each row representing a wine, and columns of data where each column represents a different chemical property of that wine. So we know the high-level shape of our data, and we know how to access individual rows within our data, but how do we look at individual columns? Like let's say, let's take a look here at our data bunch. Again, let's look at these feature names. I'm going to go ahead and pull this out into its own variable. And let's look at these feature names. All right, so, let's say that we want to look at the alcohol content for all of our data. how can we look at just that column? So, if we were to have, let's say we were to have a Python list of lists here, if we were doing this just kind of in plain Python, let's just call this, I don't know, let's call this A or something like that. So in Python, we might have to do something like a for loop, like for item in A. Then maybe we could print that first, print item 0. There we go. So we'd have to do a for loop kind of over the whole structure there and grab that first item. Or, we could condense this if we wanted into a list comprehension like this for item in A. We could do something like that. But essentially, we're still looping over the whole data structure. So in NumPy, though, you don't have to do that. You can kind of directly look at the segments of data that you want to look at without having to loop through all of the data. So let's delete this really quickly and let's see how we do that. So we've got our wine data array here. So the trick to doing this in NumPy, and this is called slicing, by the way, or indexing. So just like we passed in 0, if we wanted to kind of look at the first row of our data, if we want to specify rows and columns, this is where we can start passing in multiple values to the square brackets. So the way that you can think about this is we want to pass in some value for each dimension of our data set. So we want to say, so for the first dimension here, we want to say, some indexer here and some indexer here. So we want to pass in something for our first dimension to say what we want from our first dimension, and something from our second dimension to say what we want from our second dimension. So our first dimension here is going to be our rows, and our second dimension is going to be our columns. So what did we say that we wanted? We want the alcohol. So our alcohol content is our first column within our data. So think about it. What do we want from the rows? Well, we want all of the rows, right? We don't want to limit the number of rows that we're getting back. We want all the rows. But when it comes to columns, we just want that first column. So in NumPy, the way that we can represent all of the rows is just with a colon here. So we don't specify a number, we just pass in a colon, and that colon means give me everything. So we're saying, hey, I want all the rows. And then over here, we just want the first column. So this is where we're going to use the Python is 0 indexed. So we're just going to pass in a 0 to say, give me the first column. And now if I run that, you'll see that it looks like we're getting out all of that first column here. Let's look at our data again. You'll see that this is in scientific format down here, and this is not, so it looks a little different. But look at this first value. That's 14.23, which matches up here. And then our second row has an alcohol content of 13.2, which matches this second value up here. So it does look like we're extracting all of the alcohol content data from our NumPy array. Okay, so let's take it just one step further just to help you understand what we're doing here. So I'll delete that cell here using the letter X. It's a little keyboard shortcut that I like for Jupyter Notebooks. I use keyboard shortcuts all the time. It makes you a faster programmer. So let's say that we want to look at the alcohol, but maybe we also want to look at the magnesium. So our alcohol is at index 0 here, and then our magnesium content is in index 1, 2, 3, 4. So let's say that we want to look at both of these columns and we want to look at all the rows of data. So remember what I said about NumPy, just wants you, whatever data you want to get, it just wants you to pass in a value for each dimension and just to specify what you want. So let's just tell NumPy what we want. Well, we want all the rows again, so we're going to use that colon there for our first dimension. And then for our second dimension, we have to tell NumPy, hey, I want the 0th column, and I also want the 4th column. So if we think about how to do this, well, we could just maybe specify a list or a tuple of the indices that we want. So I'm going to say I want the 0th column and the 4th column. And so now, we're passing in a tuple as a single value for that second dimension, which means NumPy knows that we want both of these. We want both of these things. So let's go ahead and run this. And now you see that we are getting returned both of those columns. And notice how these do look a little different. So let's look at the shape attribute again on these NumPy arrays. So let's look at the shape of this, and let's look at the shape of this. So you'll notice that the first time we essentially have a one-dimensional array here. So we have a one-dimensional array that has a length of 178. So we're not doing a two-dimensional array at this point, since we're just returning a single column. But now whenever we return two columns, well, we've got all of our rows, that's one dimension, and then we have two columns now, so that's a second dimension. So, and you see that NumPy does in fact return a two-dimensional array where our first dimension has a length of 178, and our second dimension just has that length of 2 right there. All right, before we move on, one last thing. So you might be familiar in Python with, let's create our little A list again. Little A list, all right. So in Python, you might be familiar with the square bracket, the kind of the indexing syntax that is this right here. Let's create a comment. Start, stop, step. So you might have seen this before because you can use this in a normal Python list. So actually, let's create some more. I could use a range for this, and that'd be a little faster. But I want to be kind of explicit about it. So, all right. So this syntax here allows you to put in two colons and specify where you want to start in the list. So, let's start at index 2, maybe. Let's go to index 9, and let's skip by 2. All right. So if you haven't seen this syntax before, this is basically just a way that Python lets you do more complicated indexing and slicing of lists. And NumPy uses the exact same syntax here, the exact same functionality. So if we wanted, for example, to just get the first 10 rows of data and the alcohol column and the magnesium column, well, then we could use this :10, just like we might do in a Python list, to just grab, the first 5 elements. And let's get rid of shape. And there you go. Now we're just grabbing the first 10 rows. And you can follow this start, stop, step syntax to, let's say if we wanted to grab every other row of data for some reason, then we could just leave this blank to say that we want to start at the beginning. We could leave this blank to say that we wanted to go all the way to the end. And then we could put a 2 for our step to say that we want to get every other row of data. And if we look at the shape of this now, you'll see that we do have half of our rows of data. So this is how you can do a little bit more complicated indexing and slicing into your data. And you'll notice that with just these two pieces of functionality here that we talked about, being able to pass in your first and second dimension, and being able to use either this, passing in the list of what you want, or using the start, stop, step method within NumPy, within Python, you can pretty much grab any slice, any little segment, any bit of data that you want from your NumPy array now. So this is very powerful if you need to select certain parts of your data. All right, so let's go ahead and move on though to actually doing some math with NumPy. Okay, so I'm gonna copy this comment up here just so that we remember that. Let's delete these cells here. And I'm going to, let's go back to my original array here, array variable, just to demonstrate some of the basic stuff that we can do with NumPy. So one of the extremely handy things about NumPy is that you can do mathematical operations directly on the full array. So if we have our Python list here, let's say I want to add 1 to every value. Well, I can't just do +1 because Python says, you know, hey, like you've got a list, you're trying to add it to an integer. I don't know what you're trying to do. Like, why are you trying to do this? So Python's functionality does not work like that. With NumPy though, NumPy was built so that you could do mathematical operations on the whole object. So if I want to add 1 to this NumPy array, I just add 1. If I want to multiply it by 10, I just multiply the whole array by 10, and you'll see that now each value, so each value within the array gets multiplied by 10. This is called element-wise operations. And element-wise because each element within the array gets operated on individually. All right, so we can do our basic, just kind of basic math, you know, multiplying, dividing. We could do to the power, just like this. So what if we want to do some more complicated kind of functions on our array? Well, let's say that we have our alcohol data here. So I'm going to get, you know, all of our rows of our data, and let's get our alcohol content. And I'll save this out. So there we go. We have 178 data points there. So let's say that I want to find the average alcohol content of all of the wines that we're dealing with. Well, if I start typing in np dot and then I hit tab here, you will see that NumPy comes with all kinds of functions, and a ton of these are mathematical functions that you can use to operate on arrays. So let me go ahead and start typing the letter M, and you'll see that we have the max, we have the mean, we have the median, we have the min. So I want to find the average, so the mean of my alcohol data here. So if I run this, now you'll see that the mean function, kind of the default mean function here, is going to take our full alcohol array and take the average of all the values there. So the mean function is an aggregation function. So we're not doing element-wise operations anymore because the average has to work kind of across all of your data. So here we're taking all of the numbers in our array, we're adding them all together, and then we're dividing them by the length to find the average there. We can do the exact same thing to find, let's say, the minimum alcohol content here. Okay, so got a minimum alcohol content of 11. We have an average of 13. Let's take a look at what the maximum alcohol content is. Okay, so 14.8, almost 15. And then we have all kinds of other functions. We can take the standard deviation here. So here's our standard deviation of all these different values. So NumPy has a lot of different mathematical functions that you can use to operate on these arrays. Now I want to point out one thing really quickly, which is just that NumPy does have some functions like the square function here, which do the exact same thing as your normal Python mathematical, your math syntax here. So this np.square does the same thing as your normal, squared double asterisk syntax here. And I just want to point out that some of these functions operate on the whole array and return a single value. Those are your aggregation functions. And then some of them operate in this element-wise fashion where to square a number or to square all the numbers, you don't have to aggregate them at all. You're just squaring each number. So some of your functions are going to return an aggregation of your data, like the standard deviation, the mean function, etc. And then some of them are going to operate element-wise, like square here. Now, there's a concept here that I'm just going to mention very briefly because this goes pretty deep, but this is the concept of vectorization, which is what makes NumPy so powerful. So the idea of vectorization is kind of what we've been doing here. Rather than operating on a Python list, element by element, having to kind of loop through the list to do these mathematical operations, NumPy operates on the arrays as entire vectors, as kind of a single vector object. And this is what makes it so powerful and so fast, and is extremely useful for operations that are used all the time in data science, like dot products and matrix multiplication. So these are essentially where you take these arrays or these vectors and you want to multiply the values together in a certain way. And so this is used all the time in data science. And the fact that NumPy can do these vector products and this matrix multiplication very quickly and efficiently is because of vectorization. So, and this, if you really start to ask the question of why NumPy is so fast and so powerful, then that's where you're going to start getting kind of deep into the computer science of what's happening and how NumPy is actually written, like what code it's written in. You're getting into the C language at that point, which, different from Python. So the concept of vectorization and how NumPy is implemented under the hood is a pretty deep topic. You can go there if you want, but you don't really have to know it, definitely at least to get started with NumPy and with data science. Okay, now let's return to indexing and slicing again, but this time we're going to do it in a different way. And so here, let me create a new cell. Here we're going to be looking at filtering our data and filtering it on certain conditions. So let's take a look at our alcohol data again. And let's say that we want to find just the data for where the alcohol content is under some value, like let's say 13%. So we want to filter all of our data down to just where the alcohol content is under 13%. So to do this, we're going to create something called a boolean mask. Boolean standing for Boolean values like true and false, and mask, which is a word basically for an array of trues and falses that you can use to filter your data, where a true means, yeah, I want this row or I want this column, and a false means, no, I don't want this row or column. So to create a Boolean mask, or you could think of this as a filter, what we can do is we can actually just do the logical operation within Python where we say, okay, I want the alcohol content to be less than 13. And now if I run this, you'll see that we now have an array of trues and falses. So this is our Boolean mask. And so let me go ahead and call this something. I'll just call this alcohol under 13 Boolean mask. So we have this array of trues and falses where a true means that we want that row because the alcohol content is under 13%, and a false means that we do not want that row because the alcohol content is at or above 13%. So to filter our data now, NumPy makes it extremely easy. We can actually just pass this mask back in to our original data. So if we look at the wine data array, and if I just pass this in, then remember that this first value here indicates our rows. So if I kind of leave, if I leave this second value here blank, then that's kind of implying that we want all of the columns. And for this first value, I'm passing in this true false array. And so what NumPy does is it takes this true false array, and I just ran it, and you can see that these values changed a little bit. And it takes that and it uses it to filter the data. So let me run .shape on this. Let me run .shape on this to see what our data shape now looks like. So you see that we have now 86 rows and 13 columns, whereas before we started with 178. So we're down to about half of our wines that have under 13% alcohol. Now, very often we want to filter our data on multiple conditions, and NumPy makes that very easy. We essentially just create two Boolean masks, and then we use the AND logical operator to combine them. If we want to say, this and this, or we can use the OR logical operator if we want to say this or this. So we can combine these different Boolean masks in different ways. So let's say that we want, our alcohol under 13%, but let's say that we want our magnesium, we want our magnesium over, let's say 120. And that's something that I've looked up kind of before here. So do we have a magnesium variable? We should create one really quickly. So we have our wine data array. We want all the rows with the colon, and then that was at our 4th index. So we can specify the 4 here to get our magnesium data. Let's take a look at that. Here we go. All right. So let's say that we want our magnesium, what do we say, over 120. So if I run that and we look at this, we see that we now have another Boolean mask. So what we can do then basically is say this Boolean mask, we want this and this. And if I run this, you'll see that each Boolean value is essentially saying, okay, I need 2 trues in order to be true. And if either one of these values is false, then I'm going to return false because I want this to be true and I want this to be true. So we're doing some kind of Boolean algebra here. And you'll see that we just have a very few number of trues in here. So most things are false. So this is a pretty rare combination. And if I create this as let's just call it a combined mask, then I can pass this in to our original NumPy array. And you know what? Let's just look at just the 2 columns that we're dealing with here. So this is combining a lot of NumPy functionality right here in this expression. First, we create a combined Boolean mask based on some conditions in the data that we want to see. And then we pass that Boolean mask into our NumPy array in order to filter the data. And then once we filtered the data, now we want to look at all of the rows in our filtered data, and we want to look at just these columns. So we're taking our filtered data, which is this here. Let's take a look at the shape. 6 rows and 13 columns. And we're saying, okay, I want to look at all 6 of these rows, but I just want to look at these 2 columns here. And by the way, just to show you, there's no reason why you have to assign these to variables beforehand. So we can just pass these Boolean masks directly into our NumPy array to do the filtering here. So I'm basically just kind of wrapping this up and saying, okay, here's our first Boolean mask. We'll slap that in parentheses. Here's our second one. We'll put that in parentheses. And then we can logically combine these using the AND operator. And then we're just passing this whole thing into the NumPy array. And, once again, just to show you that it's the same, let's pull out just these columns here. All right. Let's get a little creative doing some if-then logic here. So let's say that we want to take a look at our alcohol content and we want to categorize this based on the alcohol content here. So maybe, if the alcohol content is less than 12, then we want to say it's low alcohol. And if it's over 14%, we want to categorize it as high alcohol content. And then anything in the middle we can do as just moderate alcohol content. So there are several different ways that you can do this kind of if-then logic, creating categories or doing if-then logic in NumPy, but we're going to start off by doing the np.where function, So let's take a look at the docstring first, np.where. So if you look, it looks pretty simple. We have a condition, and then we have these two different arrays here, or array-like here. So our condition, if our condition's true, then we want to return x. Otherwise, we want to return y. So let's just take a look at how this works. So let's say that we're dealing with our alcohol content here. So np.where. Let's say that we want to say where alcohol is less than 12. So if that's true, then what we can do is we can just return this. I know that it said array-like in there, but you can also just use a string here. So we want to return low alcohol, and else maybe we'll just say, we'll just say other. And here you go. You see that all of these rows at the top here are above 12, and so we return the value of other. But down here, you see that we do have some low alcohol content for these values that are less than 12. So that's how we can do one condition. But what if we want to do multiple conditions? Well, like I said, there are other ways to do this in NumPy, but if we want to stick with the np.where for a second, then we can just nest our conditions. So we basically say, okay, here's our first condition. If this is true, then we want to return low alcohol. If this is false, then we want to go into another condition. And specifically, what we said, right, was that we wanted to say that if our alcohol content was over 14, then we'll call that high alcohol content. And then otherwise, we'll call it moderate alcohol here. So now if I run this, you will see that we do get all of our values here. So here's a high followed by a moderate. Let's see if that's correct. So we have a high over 14 followed by a moderate, which is between 12 and 14. So that works. And then down here, we have our low alcohol as well. So here is one way that you can do some if-then logic inside of NumPy arrays. There are also ways to do this kind of logic using masks as well as some other NumPy functions that you can go learn about if you want. Okay, moving on. So sorting in NumPy is pretty easy. You can just do the np.sort method here. So let's sort our alcohol content. You'll see that the default sort is ascending order there. If we want to reverse the order, then we can use that start, stop, step method earlier, but there's a little trick, which is that if you throw in a -1, then the step of this indexing is essentially saying go backwards. So you see that we reversed the order of our sort. So this is a nice trick for sorting a NumPy array in descending order. Now, what if we want to sort not only our alcohol data here, what if we want to sort our entire wine data set by this alcohol data here? So you can imagine, if you were to have this in Excel, you have some rows and some columns, you click that alcohol column and you want to sort the whole spreadsheet by that column. How do we do that? Well, there's this extremely handy function in NumPy called argsort. And let's look at the docstring here really quickly. So the docstring says that argsort returns the indices that would sort an array. So we're not sorting the array, we're returning essentially the instructions for how to sort the array, the indices that would sort the array. And if you remember with NumPy, that we can pass indices into NumPy arrays, and NumPy will give us that data out. Well, we've basically just discovered a way that we can sort all of our data by another column. So let's see this in action. So let's argsort our alcohol data here. So now you'll see that rather than being the alcohol content data itself, these are all indices. And if you look very closely, you should be, okay, here's our index 1, here's the index 2, index 3 is down here, here's index 0. So these are the indices that would sort the array rather than the data itself. And now what we can do is let's say, let's call this alcohol sort IDXS, which is just kind of a way that you can say indices. And this is also going to sort in ascending order by default. Let's go ahead and reverse this array. And now, if we pass this into our original data array here, you will see that, well, it's a little hard to see. Let's just grab the first 3 columns. There we go. So you'll see that our data is now sorted by the alcohol column there. So argsort is a very handy function that comes in use in all kinds of interesting places, but basically what you're going to see it used for is you want to sort one array by the kind of the sorted values of another array. And so doing operations kind of like this here. All right, we're getting pretty close to the end. We still have a few more things to go through. So right now I want to show you how you can get NumPy arrays out of pandas DataFrames, because remember earlier that I said that pandas is built on top of NumPy, and very often you'll be working with pandas DataFrames or pandas series, and you'll need to get the NumPy values out for some reason, or you'll have to get them out for some reason. So I'm going to create a pandas data frame for us really quickly. Well, let's see. First, we have to import pandas as PD. And then we can say df equals, we're going to create this data frame using our wine data. And we're going to say that our columns are those feature names that we extracted earlier. So let's do that. Look at a little df.head here, and you'll see that here is our data. So we have our alcohol content, we have our magnesium, we have these flavonoids here, which I believe is misspelled maybe, or maybe there are multiple spellings of flavonoid, color intensity, hue, etc. So here's our pandas data frame now. And if we look at the type of this, you can see that this is a pandas data frame. So the way that you get your NumPy data out of your pandas data frame or your pandas series, which a series is just a single column here from the data frame, is using the .values attribute. And if we look at df.values, you'll see that we're right back exactly where we started with this NumPy array. And if we pull out a single column here, let's look at our proline, I believe is a column. So here is our proline pandas series. We look at the dot values of this, and we get that NumPy array right back out again. Now, since we haven't touched on this before, I want to reinforce it really quickly. Remember, at the beginning we said that a NumPy array is a homogeneous multidimensional array. And what that means is that you cannot have something like this. You can't have both integers and strings. NumPy needs it all to be of the same data type. And so actually, let's see what happens if we run this. You'll see that NumPy wants to create the array for you. It doesn't want to throw an error, but it needs it to all be the same data type. So what it has to do is essentially go to the, kind of the least common denominator data type here. So what I mean by that is, what is the data type that NumPy can use for all of these without throwing an error? So if we try to cast this a string, if we try to cast this string to an integer or to a float or to a boolean, then that's not going to work, right? You can't represent the letter a as an integer. You can, however, represent integers as strings. So in this case, that's exactly what NumPy chooses to do, is it chooses to convert everything to a string. And that's basically what will happen anytime that you have, let's do something like this. Anytime that you have an array that's getting created with mixed data types, NumPy is usually going to convert that to a string, because very often the string is kind of the lowest common denominator that everything can get cast to without throwing an error. So remember that this is because NumPy has homogeneous ND arrays. There we go. So that homogeneous is a key word there. All right, a couple more things. Number one, how do we create ranges? So very often we'll want to create a range of numbers for some reason, because we want to loop through it, or in matplotlib, very often we'll want to create some x values that we can then use to multiply by something, or to create a y value as well to plot. So very often we want to create ranges for some reason. So there are two main ways that we're going to do this in NumPy. The first is just np.range. This is very similar to the Python range function. If we look at the doc string here, np.range. I forgot that it's a range. Sorry, it's array range. So slightly different name here. So if we look at the doc string for the a range function, you see that this returns evenly spaced values within a given interval. So the arange function is typically going to be used anytime that we want to create a sequence of integers. So if we want to create an array, so let's do the arange from 1 to 100, and let's go by 3 or something like that. So here you go. Here is our NumPy array of the numbers from 1 to 100 with the step of 3. So arange is used when you want. So this is used when you want to create ranges of integers. So if we want to create a range that has float values in it, that's where we'll use this function called linspace. So let's look at the doc string for that. So linspace, you have a start, you have a stop, and then you have some options here. We're going to use this num option. Returns evenly spaced numbers over a specified interval. So this, for example, comes in handy, especially when you're plotting things, for example, or whenever you want to have some small numbers kind of in between a range. This is useful with a lot of, let's say, like machine learning algorithms and data science applications. So if we look at linspace, for example, let's say that we want to have numbers from 0 to 1, and maybe we want to have 100 of them. Well, here you go. Here are evenly spaced. We have 100 numbers that are evenly spaced between 0 and 1 inclusive. And so this could give us a very nice, let's say, array of x values to use to plot a graph, for example. All right, the final thing we're going to do is look at reshaping arrays. And one of the perhaps the most common times that you might want to do this is when you're dealing with some kind of image data, some sort of computer vision data set. So let's load some digits. So I'm going to say from sklearn.datasets, import load digits, and let's call this data bunch digits. We'll load that up right there. All right, and then let's say digits data. We can just call that data key from our bunch there. So let's look at our shape. Data, let's see, digits data dot shape. All right, so you'll see that we have about 1,800 rows of data here and 64 columns. So last time I checked, an image wasn't just a flat row of numbers like this, but in this case, with our digits data set, Scikit-Learn has given it to us in this kind of flat representation. So this image here has essentially been turned from its normal square format into just a flat array. Well, what if I want to turn it back into its normal two-dimensional image? So this is where we can use the np.reshape function. Let's look at the doc string here. So with the reshape function, you pass in your array. So let's take a look at the first image in our digits data set. And then we pass in the new shape that we want. So in this case, since this number here is 64, I can hypothesize that this image is probably an 8x8 square image. So let me pass in dimensions of 8x8. So this is a two-dimensional new shape that we're passing in, where the first dimension has length 8 and the second dimension has length 8, a square image essentially. So let's close this out, run this, and here you go. This looks an awful lot like an image here. And actually, if you kind of like squint at it, you might be able to tell what image this is too, because the numbers sort of pop out at you a little bit. But if we want to see what image this is, then we can just slap it into matplotlib really quickly. Let's say import matplotlib.pyplot as plt, and then we'll use this imshow, this image show method here really quick on the pyplot object, and look at that. Let's call cmap gray. There you go. So you can almost see the 0 there if you like squint a little bit. You know, these high numbers here indicating whiter pixels, and the zeros indicating the black pixels kind of around the edges and in the middle there. So, but this np.reshape method is very handy very often for reshaping image data like this. Or if you're using neural networks, like let's say convolutional neural networks or other types of neural networks, you'll need to reshape your data sometimes to get it into the right shape for the neural network. So that's where that can come in handy. Now, sometimes we want to do the opposite. We want to take image data and get it back into that flat shape like Scikit-Learn gave it to us originally. So let's take, let's say that this is an image. I'll call it image 2D here. Now, if I call the flatten method on this NumPy array, and just to show you again that this is just a two-dimensional NumPy array, if I call the flatten method, then we get back here to what Scikit-Learn gave us originally, which is just a one-dimensional array, just kind of a single vector there. And with that, we are done, my friends. So that is the 20% of NumPy that you need to know to get 80% of the value. So I hope that this has gotten you up and running very quickly. There's obviously a lot more to learn, but now you have some of the main functions and some of the main functionality that you need to know to do most of your work. So check out other Project Data Science tutorial videos, check out the website, check out some of our courses, click subscribe, and have fun learning data science. Happy learning. We'll see you later.